Okay, so here we have a piece of paper here. You should have this on your notes. You're going to need about this much space. This is going to be the most challenging diagram we've done yet. We're going to draw, and I know you can do this, you're going to draw the solar system, or at least the sun and the earth part of it, and in the middle is the sun. Hey, what's the vocabulary word that means that the sun is in the middle? You guys know this. It's not geocentric, it's what? Heliocentric, that's right. Heliocentric, sun in the middle. So here's the sun. Now the earth goes around the sun. What we're going to try to get fancy is draw it like it's an angle, okay? And so here's the earth. Now, of course, the scale is way off, but we've already understand why that's going to be. And we're going to try to draw it to where the earth's axis is turned toward the sun, or at least the northern hemisphere is. And so we can sometimes make it look sort of 3D by putting a little equator there. I kind of made it a little dotted line kind of curved, makes it look like a ball. And then here's the imaginary Earth's axis that it spins around, okay? And so the Earth is going around like that every day, and this is the position it is in its orbit around the sun. Now, this particular position has a name. It's called the summer solstice. Summer solstice. Okay, the summer solstice is the longest day of the year in the north where the tilt is maximal toward the sun. Okay, then as it orbits around the sun, as it revolves around the sun, now it looks like it's getting closer here, but I'm trying to show it at an angle, right? Give it sort of that ovoid sort of shape that way. And then here, the axis remains the same, pointing in the same direction toward the star Polaris. And so here we have, as the summer goes along, here's the summer. And as summer goes along, the days are getting shorter, shorter, shorter. Now that might confuse a lot of people going, wait a second, the summer is supposed to be the hot time. That's not some days getting shorter. Well, they actually are. But remember something I said earlier in the lesson. The temperature of the earth all depends on whether it receives more energy from the sun or whether it radiates away more energy at night in the form of infrared just shining away. It's an invisible kind of light that we can't see, but that's what cools down the earth. So the earth is in a balance point between warming and cooling all the time. Here, the northern hemisphere is getting more light, getting more heat than it's actually losing, so it warms up. Okay, and so it continues getting more than it loses. Even though the days are getting shorter, it continues accumulating heat for a while. So like in August or so, it's usually the hottest part of the year. And this happens sort of, in the beginning of July. Okay, so then it starts losing more than it's gaining. It's cooling down a little bit. Now we got this, the autumn equinox, autumnal. Now, equinox, equa means equal, right? And nox is Latin for night. Equinox means equal night, means equal night and day. So right at the autumnal equinox, oops, I was talking, I didn't write the L. Every place on Earth has 12 hours a day, 12 hours a night. Of course, in the North and South Pole, what's happening is the sun is skimming around in a circle, skimming around the horizon, but that's all right. Okay, so boop, 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 boop. It goes around some more, and here we have autumn. And the days here are also getting shorter, right? Until you get the shortest day of the year, where it's the maximal tilt away from the sun, and that would be the winter solstice. Winter solstice. Now, sol is Latin for sun, so solstice has to do with the sun. The stis part, actually, I've never looked up to know what that means. Oh man, my dotted line wasn't very good, but that's all right. It shows it going around counterclockwise. So you have the winter solstice, and so now you have it goes to this position here, which is where days are getting longer, longer, longer. Although even the coldest part of the year is around here, usually around somewhere in January, February, right? Because it's continuing to lose more heat than it's gaining. But then it starts gaining more heat than it's losing, and it starts warming up again, and this becomes the spring equinox. There's another name for it. I'm going to go ahead and put it. It's called the vernal equinox. I will be honest with you. I want you to know that the equinoxes are when it's the beginning of spring and the beginning of autumn, equal night, equal day, 12 hours of each. But I don't really care if you know the word vernal or not, but it's kind of fun. Well, I'll just put spring equinox. It's also called the spring equinox. Okay, so then it continues on its journey around the sun until it gets back to its starting point. And so here we have spring. And here we have winter. And so basically, here's what's going to happen. Well, you'll see. I'll go ahead and put together some for this. It'll be like test questions similar to this, where you have to be able to identify what each of these places on the this sort of a hand-drawn map, kind of like this. Okay, so you want to make sure you get these notes and that you could identify. Now, here's the deal. I drew it to where it was tilting this way. I could just as easily have drawn it to where it was tilting this way, and instead of this being summer, this would have been winter. And then this would have been spring, and that would have been summer because it would have been tilting toward the sun. I just happened to go in that direction. All right, so there you go. Awesome.